All right. Well, thank you very much for having me. And just before we started recording, I gave a little preamble and I talked a little bit about myself and my interests and how they've evolved over the years. And I'm fortunate to have two partners in crime with me tonight, Larry VE7VJ and Peter VA7XSK, who have worked with me on this project. I'm going to give them an open invitation. If they see that I'm off track or I'm talking about something or they want to elaborate on a point, I'm going to ask them to jump in by all means. But as I was preparing this talk, I thought, really what should be the focus? What do I want to emphasize in this talk? So I'm going to sort of address two broad topics. Meshtastic, what is it? But more specifically, what's in it for amateur radio operators? So I have to get some disclosures out of the way at the very beginning. I don't claim to be an expert in Meshtastic. I've read a great deal about it. I consider myself an informed user and an experimenter with Meshtastic. But if you're asking me to explain the nuances and details, I'm still learning. It's it's kind of a funny learning curve. Anybody can learn to use it on a basic level. If you want to get in depth, then the learning curve becomes quite steep. And that's kind of where I am. I'm curious about a number of things. But by no means take my word as gospel. I do not claim to be an expert. I will, throughout the course of this talk, bow to my PowerPoint presentation, bring up some web pages to show you some things. For anybody who's curious, I wholeheartedly encourage reading about Meshtastic. There are multiple sites. All you have to do, and I think I talk about it in the next slide, all you have to do is Google Meshtastic and a number of sites come up. What I do propose to talk about when it comes to Meshtastic is really just a very high level view of it. A quick review of what Meshtastic is, the basic concepts, what it could be used for, the techniques. Then I'll focus on ham radio aspects. But another kind of disclosure I have to make, and even the Meshtastic people admit this, which is we're talking specifications and power and things like that. There hasn't been a lot of formal testing of this. We certainly haven't done it. We're just getting things, talking to each other at this stage. And at some point in the future, I hope to have sort of empirical numbers to share with you about what the results are like, but that's not been done yet. So reading, please read. The official site is meshtastic.org, very simple. It is an open source project. The code is readily available on GitHub. I've looked at it. It's kind of interesting. I put the links. I can share the slides with you afterwards, but that's the link. I don't know why it didn't render as an actual link on the slide, but the GitHub page. There's also an unofficial site. I'll reiterate, please Google Meshtastic. There are an abundance of videos. A lot of them are how-to. The way to make sense of that is to realize that the vast majority, from what I can tell, the vast majority of users of Meshtastic are not amateur radio users. So they're not as fluent or as comfortable with concepts about RF as we are. So they're being walked, or even coding for that matter, they're being walked through right from the beginning. So you'd actually find some of the videos very informative, if not a bit elementary. Well, what is Meshtastic? And I think to understand Meshtastic, you have to understand what it's based on. And Meshtastic is based on what they call the LoRa protocol. And LoRa is just a portmanteau of a couple of words for long range. Meshtastic uses boards that are LoRa capable. Now, I'll explain this as best as I can because this is something I'm still learning about. But LoRa is a proprietary RF modulation technique. Symantec, I believe, is the company that developed it. And again, there's a link to a YouTube that explains it at a somewhat technical level. It's called CSS or chirp spread spectrum. Now, something else I'll share with you. A couple of times during here, I put things in quotation marks. I'm not doing that because I'm sarcastic or cynical or I want to call attention to it. My convention will be if I put it in quotation marks, it's because there's some ambiguity or some debate about what that means. To me, spread spectrum means like frequency hopping. You know, like some wireless routers will change channels very quickly. If you read about this, you'll find that it actually sweeps across a predefined amount of spectrum. And I'll let you figure out the rest, but that's what they mean by spread spectrum. The LoRa protocol is excellent at sending small chunks of data at low rates. Well, what good is that? Well, the point is it can do it over a very long distance, and it can do it over very noisy conditions as well. Supposedly, it is resolvable below the noise floor. And again, I've never seen tests of that, but between this chirp spread spectrum mode of propagation and some interesting mathematics, and again, it's all detailed in that video on YouTube. Some others I can send you to links to if you want as well. It's true. From quite a distance, it can get sensor data, it can get all kinds of small little packets of data and resolve them and present them to somebody. Typically, it's used in what they call LoRaWAN, the Internet of Things, if you're familiar with that. Water sensors in your garden, temperature sensors, it all comes to a central server. Not a server really, but let's just use that term for now. LoRaWAN means there's a software layer on top of the LoRa. One thing that's important, and I'll come back to this later in the talk, is there's sort of a bandwidth versus range aspect to this. If you're willing to sacrifice bandwidth, in fact, if you get down to very low bandwidth, you can achieve remarkable range, and the range can be much longer than other proprietary protocols such as Zigbee, if you're familiar with that. And again, later on I'll demonstrate this, but there's something called a spread factor. If you're familiar with the OSI stack, the 7 layers of TCP/IP, it's not my intention to go over that in detail. Supposedly, Meshtastic uses only the physical layer. Again, that's in quotation marks because there is software involved with this. But what is important to understand is that Meshtastic is based on the LoRa modulation protocol. There's a bandwidth versus range issue. And quite frankly, you can achieve long ranges with this protocol, much longer than other proprietary modes of communication. So again, what is Meshtastic? This is taken directly from that Meshtastic org. It's a project that enables you to use inexpensive LoRa radios as a long-range, off-grid communication platform. And I think you can read the rest, in areas without existing or reliable communications infrastructure. 100% open source. Deep breath. What does this mean? Well, practically, this means using low-cost LoRa radio boards that operate within the sub-gigahertz ISM bands. And ISM stands for Industrial Scientific Medicine bands. These are the ones that are typically available without license, provided the equipment is certified by, in Canada, that would be ISET, I guess in the States, the FCC, and meet certain requirements. Even more practically for us, the ISM band, the only ISM band that's really available and where the boards are available is the 902 to 928 megahertz. And if that looks familiar, that's also our 33 centimeter band. We'll get back to that. In some parts of the world, Africa, and I can't remember where else, they use 868 megahertz. Europe uses 433, which is interesting because that's part of the spectrum available to us. And I'll talk about that a bit later. So really what I'm getting at is when the appropriate firmware is installed in one of these boards, and you have more of these boards in contact with each other or within some distance of each other, these boards will detect and communicate with each other. That's the mesh in Meshtastic, and each board is considered a node. Something else you have to keep in mind too is practically, and I'll show some pictures later, the boards can operate by themselves. They have tiny little OLED screens and you have to kind of really squint to see the messages, but sending a message can be problematic. So the way they solve that is each board can be connected by Bluetooth, a network connection of some sort, or a serial connection of some sort to an input and output device. And that's how you can send messages. The boards also, even though that they're designed to send short text messages, similar to the SMS capacity of your cell phone, you can send telemetry data. People will send sensor data along with messages during Meshtastic, that sort of thing. Now, I'm leery of harvesting pictures from the internet. Our organization had a bad experience with harvesting a picture and getting a nasty letter in the mail saying you used it, you violated a copyright. Later on, I'll show some actual web pages rather than do this. I kind of changed my mind after this picture. But this is taken from the meshtastic.org, which is kind of the mother site for Meshtastic. It's not the best diagram, but basically you've got Meshtastic devices here. You've got something, let's call it an Android phone, paired by Bluetooth to one device. You can send a device to this, it will talk to the nearest device it can find. That device will talk to that device will talk to that device. That device may or may not talk to upload data to that computer. It can be connected serially. It's not as simple as a USB connection, but I'll go into that later if you're curious. Could be networked, it could be Bluetooth. Bottom line is you've got these devices, you've got something paired to it, and as long as there's another device, these devices will talk to each other. So what are the selling points in Meshtastic? Like why would this be interesting to anybody? But well, these are very inexpensive radio boards. You can get a pair of Heltex that we started with for around $60. I've seen them go up to the $150 range depending on what you get, but generally speaking, they're quite inexpensive. The whole project is open source. You're welcome to play with the code. If you know anything about GitHub, you're welcome to get in there and play with it and fork it, do whatever you want. These are fairly long range, and they achieve distance by one of two ways. They can be done line of sight, Or they can simply, if you have nodes spaced at critical intervals, let's say you have it at every 5 or 6 kilometers, one node will pass it to another, will pass it to another, will pass it to another. Reputedly, 254, I think, is the kilometers is the line of sight. And we're talking 100 milliwatt radios here. Okay. We're talking stuff that is not,
You have to be you have to be on top of Mount Everest or something to have line of sight for that far over the earth, I think.
well, this was done that's a good point. This was done in the Midwest, and somebody was on a mountain, somebody was down below. But I mean,
Yeah.
you wouldn't do it in Vancouver Island where we're up and down
No,
your train and big
no,
trees and all
no.
that. But that's a different issue. I'll come to
It's
that
more
later.
like 250 meters.
Well, hang on a second. I forgot to put it in here, but Larry V7VJ and I set up kind of a base station, and behind him, and he can explain a little bit more. There's a road. We were able to achieve about 8 to 10 kilometers line of sight.
Yeah, yeah,
So we proved that was just an RF communication.
yeah,
That wasn't network, but we
yeah,
played
yeah.
with.
No, I wasn't objecting. I was just remarking.
Oh no, it is. No, it is fast to me. I mean, to me, it's fascinating because it is truly weak signal work. And again, I'll
Yeah,
address that later in my talk. So again, it's a long range type of communication. I would say most people achieve long ranges by sort of relaying the messages. That's probably the most practical way to do it. It's offline. There's no dependence on any infrastructure. Put two Meshtastic devices together, and provided they agree on a few parameters, you've got a mesh. Doesn't need anything else. It's decentralized. There's no dependency on a central router. Low power, both in terms of power consumption, but power out as well. I have to admit, I was curious. So I went to the ISID site and I tried to read the regulatory stuff about in the 902 to 928 ISM band, what they allow. If it's frequency hopping spectrum, it's a watt. If it's location services, it's 30 watts. Anyways, it's very convoluted. But most of the boards you can get with an exceptional show later are sort of in the 100 to 150 milliwatt range, 20 to 22 dBm, something like that. And the batteries, they are reported to last 24 to 48 hours. So you could charge up, go hunting, and I'll address that use case later, and have a viable way of communicating. It's license free. Generally speaking, it's license free. If you stick to the ISM ban and you stick to with whatever the regulatory authorities dictate is appropriate for that. One thing to keep in mind is encryption is available. A lot of people put very complicated PS key keys in there. Take a deep breath. As hams, we're not allowed to use that. And when I get to the settings part, I'll explain how that's how that's bypassed. So what I put here is that sort of the low power aspect, the fact that it's license free and encryption is of interest to hams in a sense. And when I talk about kind of what's in it for hams, I'll address that more meaningfully. Other things these boards can do is some of them have a GPS unit. So I've got one, and I'll show you a picture of it later, that has a really kick butt GPS unit. I was surprised. In my room, it actually told me, I went to a map and it showed my exact position. It was amazing. You can enable it or not. It's up to you. You can upload the GPS position to a map, and I'll demonstrate that later. When configured, and again, my job isn't to get into the weeds about how to configure Meshtastic here. Again, I want to keep this a high level view, but if you configure your node to be like a router client or give it a different role, it can store and forward messages. If you configure a channel properly, you can do remote administration. You can send messages and play with other nodes. You can use Meshtastic with other apps. Now, again, full disclosure, I've just learned about these two apps recently, and I haven't really got into them too much. There's something called Mesh Commander. Having looked at it, I suspect it's a takeoff of a previous thing they called Mesh Commander, which was used it's about 8 years old, it was used in mesh networks, but this guy who's done some videos with it claims that you can use his app with a Meshtastic device. You can send messages more selectively, which you really can't do right now with the current Meshtastic software. You can operate gear remotely. In other words, if you establish a mesh with your Meshtastic devices, you can use this app to send messages and commands and that kind of thing. If you're curious, there's a couple of links to watch. There's also something called Meshmail, which is on GitHub. It's in alpha phase. They claim it's fairly robust. I'll be honest with you, I looked over that. It's not clear to me that that's a Meshtastic app as much as it's a standalone app that you would load on a Meshtastic board. But nonetheless, this has inspired people to think about this technology and how it can be used. So again, if you talk to the Meshtastic folks, where would they use it? So the scenarios they often bring up are like hunting. I'm in the backcountry and I just don't have access to cell towers. paragliding. And I'm not joking. Somebody said, I take it with me when I'm paragliding because I'm way above the cell towers and I can talk to I can see guys in the distance as we're hitting the thermals and we're soaring away there. The more I get into this though, and and they have a discourse channel and they've got a few others, when I read about it, there's definitely a prepper mentality to this, right? I'm going to be prepared for the apocalypse. I'm going to be prepared when Donald Trump takes office and there's a civil war in the States and the cell towers go down. I'm being a bit facetious, but there's definitely that notion that I don't want to give money to the man here. I want to be ready. I want to be, well, more power to you, because that's exactly what it is. Larry, I don't know if you could have anything to say about that. There's an ATAC app that was originally developed for the military. It was Android Tactical Awareness and Knowledge or something. I can't remember what it stands for, but if you give them your GPS position, it sort of tells you a map of your terrain and where you are. It was originally developed for the military so that they could get instant readings of the terrain, I guess. It's fascinating, but again, that sort of goes to the prepper mentality, right? I'm going to be prepared for everything. Most people who are not hams use encryption. They want to keep it private. Off the grid means exactly that. There's no access to cell towers. It's independent of any infrastructure. Again, this is going to be an important point to talk about later. This is super popular. We found out the hard way that the good boards sell out quickly. LilyGo, which is one of the companies that sells some very popular boards, the LoRa boards that are compatible with this, have some very nice ones. I signed up for their email. An email was sent to me at 1 a.m. By the time I signed on at 7, everything was gone. Like it's crazy. There are some maps that show local activity, and I'm going to get out of this for just a second, and I'm going to bring up my maps if I can here. Where are we? No, that's not what I wanted. Sorry, give me a second here. So there's a couple of different mapping sites, and I thank Larry for telling me about one of them. So if you elect to upload your node to this particular site called MeshMap, I'll show you just in a second. This kind of isn't accurate. A lot of people, when I read the stuff, say they don't bother to upload. So this maybe represents 10% of all mesh users. But look at Europe. You just have to zoom in a bit, and you can see. Look in Birmingham, 130 nodes. I don't know. I'm just choosing things at random here. Mind you, they use a different frequency. But if we come over to good old North America, and we zoom in a little bit more, and we get to, whoops, why am I frozen here? Don't freeze on me, please. There we go. Get to Vancouver Island. Mr. Larry, he's uploaded his node. So that's one example. Unfortunately, the controls are in the way of, I can't quite, hang on. Give me 2 seconds here. And another map that shows something a little bit different. And again, it's got a different philosophy about it, but England has got a huge number of users. It's more like a heat map. It kind of shows where the areas of activity are. There's a group in Calgary. There's a group in Edmonton. Same thing. If we zoom in on this, you'll see that it resolves to V7 VJ has uploaded one of his nodes. So again, all I'm pointing out with this is that there is a ton of activity out there.
But there's none in Victoria?
Well, Larry said he saw a node in Victoria once, and I've never seen it personally, but I don't know if Larry wants to address that, but. You're muted, Larry.
Yeah, I just realized that. Yeah, when I first looked at the map, there was one node in Victoria, but on that particular map, you can upload it to be on permanently, or you can, like some of them are blue, some of them are red. You can put a temporary. I just want my node to show up for the next day or week or month or something, and then it vanishes. So, yeah, there was one in Victoria, but it's gone. And there was another one on Maine. Was that not Maine Island? One of the islands down there, but I don't know if it was still on the map there. So
the bottom,
I should look for it. Sorry.
Yeah. So the bottom line is basically there's not a lot of activity, at least a visible activity in the Victoria area, and it's
not that we're aware of. Not that we're aware of. Not even up where we are. We run a special interest group. I'll tell you about that later. But
yeah.
So how does Meshtastic work? This is the ultra simplified, not doing it justice kind of explanation. But okay, so I've got a device. and it's connected to something that I can generate a message. So the most common scenario is it's paired by Bluetooth to my cell phone. My cell phone has a Meshtastic app. So a message is sent from that device over Bluetooth or Wi-Fi, the internet serial, to a node, which is, just to remind you, a Meshtastic LoRa board. There is one device that acts like standalone. I'll show you a picture of that later. The message is broadcast by the node. Any other node that received this message then discerns something about the message. So basically, it's asked a question: has the receiving node seen this message or this packet before? If yes, it discards it, doesn't do anything with it. If the answer is no, then it has to decide whether to rebroadcast it, and it will rebroadcast it depending on what they call hop limits. So if typically most people set their hop limits at 3, and I'll demonstrate this with a picture later. I sent out a message. It gets to the next unit that receives it. The next unit notices that the hop limit is not 0. In this, it'll send it out with a reduced hop limit of being 2. The next unit gets it, will send it out with a reduced hop limit of being 1. Once a unit gets it where the hop limit has been reduced to 0, it will not be rebroadcast. And based on practical experience, they say that the 3 is usually enough. But essentially, that's how it works. I get it. My node gets a message or a packet. Does it or does it not broadcast it? It's really no more complicated than that. There are some things that happen in the background. There's when you boot up or turn on your node, it does sort of figure out who's around. There's some acknowledgement and confirmation messages. Depending on how it's configured, it may broadcast again. Nodes can store up to 30 packages or packets. You can go through them. But in quotation marks, I've asked the question: is this a true mesh? The truth is, when I've looked into this, there's really no consensus about what constitutes a mesh network. In the strictest sense of the word, if you look at sort of what the current standard is, the 802.11s something or other, really each node should be assigned an IP address. Each node should have a routing table. In other words, it acts like a real network. And that's sort of kind of how Arden works. I'm not going to say too much about it. They've got something called OSLR and whatnot that sort of do that stuff in the background. You don't really see any of that here. This is more almost like UDP, if you understand what that is compared to TCP/IP. I'm just going to broadcast to everybody. And whoever gets it can decide what to do with the message. They either pass it on or they ignore it, right? Yeah, okay, it's a mesh. It's a mesh because a message brought to one is broadcast to others. What can't be done really well right now is if I wanted to send a message just to Larry, let's say about 2 or 3 people on the message, that's a bit problematic. And the developers of Meshtastic have said, we understand that's something that the community's asked for. It's just not a high priority right now because this is meant to be decentralized off grid. And there is a way to sort of do privacy by setting up channels. And again, I'll get to that a bit later. One more thing to think about is the Meshtastic meshes. So you've got different meshes can communicate with each other over the internet or some network. Now this is, I'll show you a picture which will clarify this hopefully. But before I get to that, they use something called the MQTT protocol, which is also how the Internet of Things communicates. There's, instead of a server, it's called a broker. If you remember before I called it a server. And they use what they call a publish and subscribe model. If you're curious about this, I've read a fair bit about it. In the question and answer at the end, I'd be happy to address this. And more about what this could be very interesting in terms of leveraging what's in it for hams. But let me show a picture. And I'm going to show this picture again later in a different context. But when I started contemplating Meshtastic and how it could be used, I thought, well, maybe we could marry it to the Arden network. But I'll talk about that a bit later. What I really want to point out at this stage is when I talk about 2 meshes communicating with each other, never mind my mislabeling of person 1 and person 2. That's was for a different reason. You've got one mesh group down here, and they're all in RF communication with each other. They've all got a device. All the devices are talking to each other. You've got another group up here. This mesh can communicate through an MQTT server to that mesh. And in fact, they make a public server available. There's one that you can, as long as you can join a Wi-Fi network. So that's a very interesting application of this. Now, it kind of defeats the purpose of being decentralized and off grid because you're dependent on the internet. But for sure, this part is decentralized and off grid and all the rest of it, right? These people don't necessarily have to. Somebody has to enable a mesh device to join a network and then upload the data and download the data. But all I want to point out here in this diagram is that this mesh group 1 can talk to that mesh group 2 over some sort of a network connection.
What's the speed of transmission?
Can I get to that in a second? I've got a very interesting slide to show
Okay,
you. I've got
okay.
a very interesting slide. That's a good. So again, I'm not going to get into the how-tos because there's tons of videos out there that walk you through it, but I just sort of what a ham might be interested, right? So if you're curious about experimenting with this, get a device or two. I would get 2 of them, and I'll give you a suggestion for a device in just a second. They're not super expensive, and you can play with them and see how they connect. Consider the costs, consider whether you want GPS activated, consider whether you want to get access to GPIO pins. And I should have explained it here. General purpose input and output pins. If any of you have played with Raspberry Pi and the headers, those are GPIO pins. They can read high, they can read low. You can actually use GPIO pins with a lot of these devices as well. You have to think of the radio module being used, the battery, how to connect. A lot of them use these 18650 batteries, these flat tops are becoming more popular. Some of them are just powered by external power. Semtech, which is the company I think that developed the LoRa protocol to start with, developed a couple of radio checks. We like this one. Oh, what happened? We like the 1262 one because it's a little bit more powerful, but some of the older devices still have the 1276. Again, if you're just going to play with it, it makes no difference. Most of them don't come with cases. So if you have a 3D printer handy, that's good. If not, we can tell you afterwards kind of how we're solving that. But once you get your device, you have to flash the firmware. The best option to do that is to use a web flasher. You literally plug your device in, you read what, depending on whether you're Linux or whether you're Windows, all the instructions are there. You have to figure out what COM port you're using. And then you tell, the web flasher gives you choice of device, gives you a choice of firmware. You tell it what COM port you're communicating with, and it'll flash it for you. And then once you've flashed it, you can access and adjust your device either through your Android app. You can pair it right away through Bluetooth. You can do it through a web interface. So there's flasher.meshtastic, there's client.meshtastic. My preference, and I'm the only one in the group that does this, is I like what they call a command line interface. I'll actually bring up my Windows or Linux command line. I've installed Python, and I go Meshtastic and I do something. I find that to be very powerful, and I find it gives me all the options which aren't necessarily available. So again, choose a device, kind of think about cost, what you want to do with it, install the firmware, and then adjust the settings. So what settings do you have to adjust on your device? Well, it depends on the board. For reasons I'll get into later, we've stayed with the 915 or the 33 centimeter boards. You'll need to set the region to either US or Europe. And that's just a shorthand for saying in Europe, in what are we, region 2 or whatever, our ISM band is 902 to 928. So, Canada, US, Mexico, I think part of South America, we all 915. Europe, they use 433. The reason I put it up there is it's conceivably an option for hams because we can access that part of the spectrum, right? If you're licensed. You have to agree on what they call the modem presets, and I'll show you a picture of that later. You have to agree. You don't necessarily have to do this, but you should figure out the role. Most people leave theirs on client. You have to figure out something to do with the channel. It means one of two things in Meshtastic. Again, I'll demonstrate that. If you're setting this up for amateur radio, then you can enable ham radio settings. You can say, yes, this is going to be used for ham radio. Here's my call sign. Supposedly that disables encryption, supposedly allows the maximum power on the chip. But this is where it gets tricksy because there's another resource I read that says, well, yeah, you can use maximum power. We don't recommend it. Set the setting to 0 because that's the maximum power given your duty cycle, blah, blah. In other words, you don't want to wear out your chip, right? And that might be only relevant for specific gear. There are some base stations sold that can put out 3 or 4 watts, and you need to have a ham license to be able to operate those at full power. So what devices? I'll show you some of the devices we're using. This is a picture taken today, as a matter of fact. Larry and I were chatting over the channel we have set up, and we were trying to coordinate some calls. We've done, just as a by-the-by kind of comment, we've been doing some experimenting with 2-meter USB, and we've been chatting happily with each other. We've done some 70 centimeter USB. He has a radio that he wanted to try FM on, so we were just coordinating a call. So that was kind of the last message I had there. These are the Heltec version 3s, and they're nice little units. You can get 2 of those. I put mine in the case they provide. I don't think the other 2 guys did. $60 in that range for a couple. I've got about 6 or 7 different types. I'm only going to show you a couple of representative. I've also got this TB Supreme. This is that 1262 chip I was talking about. When I set up my base station, which I'll show you in a second, and I take my dog out for a walk, you have to know where I live in Qualicum Beach, but I'm fairly close to the ocean, which means basically everything is going up to one side of me, everything's going down. So I can walk down towards the ocean. I'm talking through rocks and trees. I can still talk to my base station. I can walk up through a little forest pathway we have up here. This is an impressive little unit. I just don't have a case for it. But this will have it maintain an RF link with my home radio, which is this one. I just don't have it set up at the moment because but I repurposed one of those. I think they're for Helium Network, LoRa Network, something like that. It's I tested it and I did a little bit of tweaking and I got it centered on 915, the SWR centered on 915 megahertz. And this one will put out about 4 watts at in the 33 centimeter range. The guy who sells it says you must have a ham license to access it. He's taking, so anyways, that's the one device where entering your ham credentials does allow higher power. So I said there was one sort of standalone product. Just for sake of, oh, no, that's not what I wanted. My apologies here. I clicked the wrong button. This is an interesting little device. So far as I can tell, this is the only device that is LoRa Meshtastic capable that also comes with like a keyboard. And we looked into it. Larry in particular did some digging with it. People describe it as a bit wonky. There's a tracker ball, which is a bit fragile. It's not super expensive. I'm tempted and I'm not to get it and play with it. It also does not come with a case, unfortunately. But there is, like I say, there is this one standalone device which in theory could be used by itself to communicate with other devices on the mesh. So let me give you some practical examples. These are screenshots from my app that I've got on my Android smartphone. So we set up a couple of channels, and this channel means one of two things in Meshtastic. And again, this is where you have to read and kind of reread. Channel either means a container for communication. In other words, we set up one channel. The channels are numbered 0. You're allowed 8 channels. They're numbered 0 through 7. We set up Qualicum 0 and Qualicum 1. In order to talk with me, at the very least, you have to be on Qualicum 0 or Qualicum 1 channel. So it constrains it. Only people on the channel can talk with other people on the channel. So that's one use of a channel. The other use of a channel is the frequency. And there's a weird thing they give you. You set your region. Yes, this is US. Yes. What frequency slot do you want? So frequency slot 60 works out to 916.875 megahertz. And we'll get to the reasons why we chose that in just a second. But you have to be careful with it. And here's just an example of some of the messages. So we were chatting earlier. We were getting things ready for our 2-meter QSO. We just tested our other channel. Here's a picture of the group. Both of us are just communicating now by network. I've got one device attached to my network, and I'm communicating to it that way. So I access it. Remember I said you could access it Bluetooth, you could access it Wi-Fi, you could access it serially. I didn't get a serial one set up for demonstration, but I'm accessing mine over the network right now. It advertises its IP. I just click and I can access it. I called it VA7LMP9-2. This is the group right now. I can see 2 of Larry's nodes, V7 VJs right there, and it tells me that I'm getting them by MQTT.
So that 10009, that's UDP?
You know what? That's a good question. It's more. I'm going to be honest with you. I'm not quite sure. I'm not quite sure how, and I can look this up because you've asked a good question. I'm not quite sure how the device is talking with me over my local intranet, right? This is just my local area network that it's connected to. So 10.0.0.9 is whatever my home router assigned to this device when I signed it up to my home network.
Yeah, okay.
Is it UDP versus TCP/IP? I don't know. I really don't know. I'm going to have to look into that. That's a good question because that has some interesting implications for development too, doesn't it?
Yeah.
Yeah. No, you're right. You're absolutely right. So this is my cue to show you some web pages. So if you'll going to have to do something a little bit awkward. Unfortunately, at the very top of is this screen. So let me show you. This is from the LoRa, the site itself. Remember I said I was a little bit reluctant to harvest pictures from the site. So I thought, what the heck, I'll just go right to the web page. So it demonstrates exactly what I was saying, the number of hops, right? So there's some Meshtastic app on a device. You've sent a message to your first one. A Meshtastic node receives it and sees that the hop limit is 3. So it decreases it by 1, sends it, another node receives it, sees that the hop limit is 2, so it can rebroadcast it, but when it sends it, it decreases it by 1 until it gets to 0. This one will not rebroadcast. These theoretically could also, these will show the message on the display, on the OLED display. If they were paired with a device of some sort, they would also show the message. This last node that is not going to rebroadcast it but it should say here is 0. The hop limit is now 0. Will not broadcast anymore. This goes into the transmit power. In the settings, they talk about using 0. That seems to be the convention for the motion. I'll get to spread factor in just a second. Again, there's tons of settings you can play with here. It's really interesting. So the radio settings. Somebody asked me a question before about speed of transmission. This is kind of where the rubber hits the road on this one. So let's go back to the LoRa protocol. So there's a little chirp. It's sort of there's a little over a defined bandwidth, a frequency. It just goes up, and at certain intervals, it does things which encodes the data. How wide of the bandwidth it accesses is what they call the spread factor. So I'm probably not doing the explanation justice, but if it accesses more spectrum, it's able to get through the noise easier, but it doesn't go as far, right? It goes further, but you can't transmit data as quickly. If you restrict the chirp to a smaller chunk of spectrum, in other words, don't let it spread out as much, you get much faster transmission of the data, but it doesn't penetrate the noise floor as easily. So if that convoluted explanation doesn't make any sense, what they're really talking about is the spread factor. And the spread factor is, I don't know why they have 6 here, but they talk about it being from 7 to 12. I'll encourage you to watch the video to make sure it makes sense. But this is kind of, I think, what you're really talking about. Where are we here? Look at the data rate. It drops from 37.5, which isn't huge, to 0.046 or something like that. We've been using, and I don't know if I have it here. Yes, here's the other slide, Jemima. Oh, and there's the spread factor, 7 through 12. Sorry, that's what I meant to show you. We've been experimenting because we were doing initial experiments with just RF communication with long slow, which theoretically has 0.18 kilobits per second, which is like nothing. We actually found that worked fairly well for short messages. Not a lot of lag. It got 3, 4, 5 line messages get through quite easily. I think there's an 80 character limit. There's some limits, but that's changing as we speak. Most people it's really just like you would text somebody, right? Just a very short message. So really just wanted to show that. Kind of an answer to the question. What else? That may be all I want to show there. So what is in Meshtastic for hams? Let's get to the meat of the matter. Well, we started a group to look into this. So this is one of the Mid-Island Radio Association special interest groups. With time, we acquired the name Lamplighters. And the history, if this is what it is originally we thought, we're going to look at LoRa, we're going to look at Arduino, we're going to look at mesh technologies and M17, a new digital protocol. We're going to look at Raspberry Pi. We're interested in spectrum that's not normally used, like 33 centimeters. So we called ourselves Lamp 33. Somebody sent out an invitation saying, well, these are the Lamplighters group. So that's what we're called. We're the Lamplighters. And we meet by Zoom every Monday night at 7 p.m. We decided to experiment with Meshtastic initially for several reasons, mainly because it was available. It's inexpensive, it's well documented, and we considered some use cases. The main thing I pitched at the beginning, although it's expanded since then, is this could be an extension of ARDEN, the Amateur Radio Emergency Data Network. And I'm going to emphasize this again. I'm not here to talk about ARDEN. You'll get an opportunity to hear an expert or two talk about that. But basically, it's a standalone network. The internet goes down, you've got ARDEN because you've got robust RF links. So if you'll allow me to get out of this and get back into that document, I showed you later. This is kind of what I had in mind of putting Meshtastic using the Arden network as a backbone. So somewhere in the Arden network, there would be one of these MQT servers. It would be a gateway. There would be a couple of different things to do. One user with a standalone device could access the network and talk to anybody over here. Somebody who doesn't have a device could access it using a web page. There's some interesting work on serial sockets and Chrome and so on and so forth. Make a long story short, you could probably, and this is where a lot of the Internet of Things is going as well, as a lot of stuff is being delivered to web pages and a lot of stuff is being sent from web pages. So this is just a personal project of mine to work on some code to use a web page. So in other words, once I've got an MQT server set up, you don't need a device. I'll simply advertise on Arden where the web page is. You go onto it and go, Scott, I need to talk to you. If I'm in a mesh somewhere, I can communicate through Arden to that mesh. So you can see where I'm going with this, which is we've already got sort of one network technology. There's another one that would, excuse the play on words, mesh very nicely with it in a variety of ways, either mesh to mesh or one user to a mesh or somebody using a web page or just a standalone app talking to the mesh. Hello, I may not be at my computer all the time, but I've usually got my cell phone with me, and my cell phone's connected to my mesh. Scott, I need to talk to you about something. There's the message. Get on the computer and talk to you, right?
So that would be an app which you would create in Python, I guess. Is that right, Scott?
Well, yes and no. HTML, and I've read several times how to access this socket, the layer that they've got, and it's very interesting. And the HTML script can invoke some other scripts, which could be Python, which is what I'm most familiar with. I'll just leave it at that because I'm really growing and learning in that area.
Not important at this point.
No, I mean, to me, it's interesting because those who don't have a device, if they still want to get a hold of me, here's a way. Just go to your Arden enabled router, go to my node where I'll advertise a web page, go to that web page and say, Scott, I need to talk to you. And that message will get to me somehow, right? That's all I'm looking at is robust ways of getting the messages out.
That'd be super cool.
Yeah. So what's in it for hams? A little bit more. As hams, we have access to the 33 centimeter band. Keep in mind, we're secondary users. We can use higher power limits. When we looked into using this, there's an interesting little rider there saying, feel free to use it. Here's the band plan. If you're going to run higher powers or set up a repeater, coordinate with ICID. So talk to your regulatory authorities. We had two. I think we've only got one 900 megahertz repeater in BC right now. So obviously it's doable. We are primary users on the 70 centimeter band, though. So why don't we use that one? Well, we elected to start experiments in the 33 centimeter band for a couple of reasons. We monitored it for a while. The middle of the band seemed fairly quiet. When we looked into the software, because you have to buy the right board. It has to be 433 capable, and you have to call it a European board. They only have 4 frequencies that they allow, and some of them are dangerously close to some other allocations. Like New Packet Radio has just got a allocation 433.3, I think it is. The EME, the Moon Earth Week signal people, were actually concerned about New Packet Radio because they work in that area. There's some other emerging digital modes that are staking out territory. I don't want to talk about it today, but again, I can talk about this in the question and answer period. There's something called LoRa APRS, which is fascinating to me. They use LoRa, the same modulation protocol, but for APRS type data. And they claim that these 100 milliwatt radios can do just as much as your 5-watt VHF APRS. It's fascinating. And there's a guy in Canada who's developed this communication telemetry system, or CATS, that he hopes will replace APRS. I bought a couple of his things. I'm playing with it. He claims 433.5. So it was just crowded, and we didn't want to kind of step on anybody's toes. Besides which, 33 centimeters is just not a well-used band. So we thought, well, let's exploit it. Let's see what we can do with it. Well, what's in it for hams? To me, this is technically interesting. I've already sort of run one scenario by you guys, which is we have to we can see the capacity. Now let's make it work. It's not just a plug and play kind of solution there. This is truly weak signal work, right? So that means we have to muck around with antennas. We've looked at, I think Larry has a Yagi. I've got a couple of sector antennas that I bought for other reasons. I've played around with Feedline, LMR 400. I've got a little section of LMR 600. You can experiment with coding. Maybe there's a more efficient way to transmit messages. As I mentioned before, most of these devices have these GPIO pins. So there's a possibility of sending a message and using what they call a GPIO mask. In other words, you can use that mesh to remotely operate something. I've done a fair bit of experimenting with serial communication. A couple of computers, I pulled out a program that can communicate serially. I hooked it up using an EOART device. I'll explain that if you don't know what it is. And I got units talking to each other. And I've experimented, and I think with my FT818, I was able to send cat commands. Like the manual publishes what the hexadecimal cat commands are, and it's a little bit, the workaround is a little bit wonky, but in essence, I was able to, from my cell phone, tell my FT818 to change from packet 1200 to 1296 or something like that. I can't remember what I did. So there's lots to experiment with here. I'm getting to the end, so here's my challenge to the group. Put another way, can you see any uses for an easily deployable, robust, rugged, ad hoc mesh network communication or meshed communication network that can be linked to other such networks? And this network could pass not just messages, but commands and other data to the local or distant networks. You know, we have access to other frequencies and higher transmitting power. Why not use Meshtastic within that scope? There are amplifiers available. There are LoRa amplifiers that are available for the 915 and the 433. We could look at them. I didn't want to commit myself to writing here, but I wonder how many people thought, ad hoc network doesn't require anything decentralized. Perfect solution for EMCOM, emergency communications. And I'm just going to share a personal opinion, and I'm welcome to I will take it on the chin for this, but I'm going to take a deep breath here. In Mid-Island, there's been this discussion recently and angst almost that somehow amateur radio is losing its EMCOM function, because that seems to be our reason for existence, right? That we're granted the access to certain parts of the spectrum because in exchange for that, in the time of emergency, we may be called upon to pass traffic. Yes and no, in my opinion. I don't practice EMCOM. There are some groups that go out and drill and practice. Hopefully they've got equipment that they check and service all the time and is ready to go within, you know, limited period of time, and they've got all their protocols down, but I don't. And if you go to the ISID website, you look at what the purpose of amateur radio is, it doesn't mention EMCOMs. It just says, we're giving to appropriately licensed individuals, we're giving you this to play with, to experiment with, to play with, to have fun with, right? So sure, there's an EMCOM piece to this. I get that, you know, break out the Meshtastic, let's go into a field and communicate with each other as we set up our radios. I have no objection to that at all. But I honestly think there's way more to Meshtastic than just the EMCOM. And I don't even think that EMCOM is the be all and end all for what we do in amateur radio. In fact, I'm willing to state that as amateur radio people, think of FT8, for example. You know, we push what we've got to the limit and we find ways to make it work. And you know what? That gets adopted by other people, including the military. So to me, the whole point of this is let's experiment. Let's have fun with this. A lot of people have done work on Meshtastic. We could ramp it up a notch with our expertise. And again, it sort of leads to my last point. Keep in mind that Meshtastic has been adopted mostly by non-hams. I've seen all kinds of discussions where people start asking questions. Well, what can I expect about radio propagation? What kind of antenna should I use? I want to set up a node on the hill so people can talk to it. You know, tell me how to set up a station. What kind of coax I should use. It has excited people about radio technology. We could offer value to that community. I hope we have a deeper understanding of many aspects of this, and we could partner with them, if not actually work with them, to say, look, you know, we can give you advice and tell you how to make the most out of it. And by the way, since you're so excited about radio, what about getting your ham license? Wink, wink, nudge, nudge. You know, let's get some new blood in there. Got to be careful with the encryption piece, though. A lot of people are excited about having a private network where it's not encrypted, right? I guess I mean, there's nothing stopping you as a amateur operating encryption. You just can't invoke the amateur privileges. That's all. But like I say, I think Meshtastic is a great introduction to our application, and we should be embracing it. We should be talking to the people that are using it and say, look, we've been playing with radio for years. What can we do to help you? You know? And I'm going to leave it at that and invite any questions, thoughts, discussions. I'll stop sharing so we can all just see each other.
Very good presentation. Very good presentation, and it's a good introduction to that topic. And
Thank
so
you.
thank you very much.
I appreciate the feedback. Thank you.
Yeah. I just got a few comments while you're chatting. I was jotting them down. If you do get one of these and you go to flash the firmware to it, you've got to be sure you upload the drivers onto your computer. It's on the web page. There's 2 or 3 of them there. There's 2 of them for Windows. I can never remember which one, so I just download both of them, and away you go. That kind of messed me up because I did it on my desktop, and then I got another unit, and I was sitting on my laptop going through it, and then realized, oh yeah, I got to go back to the drivers. With the hops, there's this firmware is being updated fairly regularly, and several iterations ago they changed the way the hops were done. It used to be it would go to the nearest node, nearest radio. Now it looks for the furthest one with a reliable signal. Just try and get it a little more coverage and get around. The example the guy used was, say, someone's around a hillside and you've got all these nodes in between you. It'll go out and it'll figure, okay, I can reach that. It's furthest one away, weakest signal, but it's solid. It'll do it. What else did I have? Oh yeah, if you get playing with these, as Scott and I found out, and we tried to get MQTT going, would not work for us at all, and probably my fault because I didn't read all the little preamble when I updated. I had the most recent version of the firmware, and I think he was 1 or 2 behind. And the version I had, there's a big warning at the front: if you load up this firmware, you'll not be able to talk through MQTT with anybody with older firmware. So, make sure you keep it up. And there's 2. When you go to the site, there's an alpha and there's a beta. The beta tends to be the more secure one. And when you were talking about sending like directed messages, you can do that. I don't know when it first showed up, but I never have any luck trying to get my. Is that going to show up here at all? No, it's not going to focus. Bugger. No, we get kind of it. No, I can't get it to focus anyways. Anyways, you'll get when you get into it, you'll get one of the screens has a list of nodes, and you click on one of them, and oh, that's my one. You click on it and you get direct message as the first one that pops up. I don't remember that being there before. So as I understand it now, if you're in, say you've got 10 people in a mesh, you just want to send a message to one of them, you click on their little node in the node list, hit direct message, and it should just send a message to that particular node. And the other things, you can request position, like if they've got GPS running, you can forget the node entirely, you can send a tracer route, or you could ignore it. There's a couple of options. So, but I will back Scott up. It is a lot of fun to play with, and considering how tiny these little as these little radios are and how much they got packed into them, it just amazes me what these things can do.
There is a nuance with that direct message, and I didn't want to get into it. I'm going to have to look it up.
Yeah.
You're right, Larry, and it's not as black and white as I painted it, but you need something enabled, and it's a little bit tricky. Anyways, yes, okay, I stand corrected on that point. There is a direct message capacity to it, but it's you need the most up-to-date firmware, and there's something that needs to be enabled. I can't remember what it is.
Yeah. Well, that is one thing with a lot of this. Some of the stuff, yes, you could do this, but you've got to dig into the settings and make sure you've got it configured properly. So it will keep you
Apologies
busy.
for that faux pas. Sorry about that. So it is possible, and I forgot that there's a way to do it, but it's a little, like I say, a little bit tricky.
Any other questions, gentlemen?
Yeah, I have a
Well, let's-
question. How would we bootstrap ourselves up into Meshtastic in Victoria? Obviously, if I set up a node, I'm talking to myself.
Well, there's 2 things you can think about here. First of all, consider joining our group Monday night. And anybody who's interested, I don't mind Glenn passing along my email, and I can send the credentials. It's a Zoom link, but it's password protected, so we don't want to publish it, right? You'd be welcome to join. And you can be on the other side of the world, and we can talk to each other through MQTT. So if you got a couple of devices and you were willing to enable one to join whatever Wi-Fi you've got, make it a gateway node, then you could either join on one of our channels, or we could create a separate channel and you could join that and then talk to us. That wouldn't be a problem. And then anybody else in Victoria could do the same thing. Either that or just put out the word. I'm interested in playing with Meshtastic. Who else has got a unit that's available? But you're welcome to join our group and learn more about what we're doing.
I can quite easily, for Kurt and others who are really interested in this, and it's a fascinating topic, and I have to concur with Joseph. This has been one of the best Zoom calls we had. So the other ones are very good too. This has been top notch, Scott. Thank you.
Well, thank you.
Certainly a heck of a lot to chew on, that's for sure. I will, with your permission, Scott, I will send out an email to the members, just the members, because Andy has helped set up a mailing list, of course. And I'll say, anyone interested in Meshtastic? Here's Scott's email address, and if you haven't been able to, if you weren't able to get to the Zoom call tonight, Andy's going to have it put together pretty quickly, and I'll get a link out on the website, but also I'll send it out to everyone once again via the members' email, because it has been top notch. Technically, a lot of really cool stuff to chew on. And hopefully we'll be able to get a bunch of people really interested in Meshtastic down here in the Victoria area, because we've got a ton of people. It's great to see the numbers here tonight. And it's great to see two of your colleagues here tonight, Scott. It would have been delightful to see twice as many others, but I know John, he could be Scottish dancing tonight, but he's come on to the call here, Mr. Erskine. So it's great that he's been able to join us because he's quite an experimenter too. So Mr. Erskine, did you have any questions? Because generally your mind is spinning on this stuff. Do you have any questions this evening?
I just wanted first off to thank Scott. I agree with the others. It's a stunningly well done and presentation. I've played with a bunch of things over the years, not this yet. I've been sort of sneaking up on it. A friend has bought me one of the little devices. I think it's that little green one that makes it look like it's a thumbs up thing. So I'm looking forward to playing with that. And I've got a Swap Fest pickup of about a 12 element 902 meg band Yagi Uda, and I've got my discone hanging out on the balcony. So we'll see what happens there. In my prep, I've been casually viewing a bunch of the sort of how-to style, though some have a little bit of videos online, mostly YouTube, and most of the sources are in the UK. So one of the fellas, his surname's Ringway. That's why his YouTube channel is Ringway Manchester. And he does a lot of cool other video stuff. There's Tech Minds. And then Andy Kirby's he's an enthusiast, but I take his stuff with a bit of I would say a grain of salt. So I've been hitting those up. But I'll tell you that the way you broke things down, it's really helpful for me so that I can sort of go on, I think, now to the next phase of things. So yeah, I've been messing with a bunch of different data protocols for some time, and I can see some of the similarities. I know some of the language you're using, some of it's new to me. It's very cool. Thank you.
Yeah, that's
My
great.
pleasure. One thing I'll put out there is I'm excited of all those other technologies I mentioned. I'm also excited about this LoRa APRS. And the boards for that run about $30. Like they're ultra cheap. And if you're curious about it, let me know. Just again, Glenn will put out my email. I can point you to some resources. They're in German, but there's a way to translate it if you're curious. But you have to compile and flash. It's a little bit techie kind of, but you can make them as a digipeater. You can make them as an iGate. And they claim, because it's LoRa, that you can be quite a distance away and operate on milliwatts. Like you get the same distance as you do with APRS. And I'm thinking, okay, there's some cool stuff with this. It's LoRa writ large, right? Either Meshtastic or APRS, but
and it's only milliwatts versus watts, right? With standard APRS.
Yeah, Like, I mean, 100 to 150 milliwatts, 20 to 22 dBm, something like that. I can't remember. 22 to 24, I think is what it comes. Um, but they're milking the notion that this LoRa does have an ability to be propagated over long distances, and you're passing very simple data with APRS, right? My position every so often, a little very simple message, a little icon that's, UTF encoded sort of thing. That's kind of the next thing I'd like to experiment with. I'm tempted to, go to AliExpress and get 2 or 3 of those boards, and not even $100 shipping, and play with them. So there's tons of stuff we could do with this. Tons of stuff.
Joseph, you're in deep thought there, and I know you like doing this stuff. Have you got any questions or any thoughts?
No, I think this is very interesting. I think the kind of application for that is kind of very specific to project. You do a little project, somewhere, in the bush or whatever, with some type of sensors or monitoring some stuff, and you can do it without talking to anybody and asking anybody. You can do it with 2, 3, 4 people, whatever system. So I think, if you are a curious person, and dealing with some kind of data gathering, of whatever sort, you can have a very interesting project,
Absolutely. Absolutely.
Actually, I had the questions, and so the way I understood, you can connect those devices to your own server, and you can. So how do you protect your server or the rest of, of your server from inputting messages that you can get from those devices, which could include a code, any kind of code can be transmitted as well. So how do you protect yourself from that in that system? Does that make sense?
I do, and the reason I'm struggling to answer is I'll explain the concept, and then I'll get you to rephrase the question. So, do you know about MQTT and the Internet of Things? Again, this is a steep learning curve for me. I've had to read about this over the last couple of months. So,
Not as much as I should.
okay, all right. So it's not a server, okay, as such. It's what they call a publish subscribe, and they call them brokers.
Okay.
So you got to keep that in mind to start with. So once you've enabled your gateway node, whatever that is, there's tons of information about it. I've been playing with something called Mosquito. You can download the code. You can set up your own MQTT broker if you wish. And that's kind of what I want to do in Arden eventually, right? It'll be secure because only people can access it. You have to have a ham license.
Okay.
You can put encryption in there if you want. You can, there are various ways of making sure that only authorized people can access it and get it. In this case, there's a password. They publish what that password is for all the good that does to get into their public broker. So I don't know if that's a full answer to your question, because I think, are you also concerned about the actual traffic containing something malicious?
Well, we live in a strange world, and all those technologies, avant-garde technologies, they call it, if you want to put this into your own working station or server, there is some precaution to take, and for instance, for my own station there, my radio computer, is not connected to my main working computer for my I don't do so I don't do my banking on my radio computer. I don't do my income tax. So I can to isolate those things because the world out there is too complicated for me to really grasp it. And so anyway, I was just
No,
I'm not.
I listen, I take computer security very seriously. I'm totally on board with you there.
Yeah.
I do something similar. I have an old Windows 10 machine that I use just for ham radio stuff. And I'll just leave it at that. What I'm talking to you on now is it's an older laptop that's due to be replaced anyways, but I run a couple of different types of I use Kaspersky, full disclosure. Yeah, I know it's controversial for other reasons, but it's very robust. It's saved me a number of problems. I'm looking at setting up something at home called Pi-hole, which is a very interesting, you know what that is. So I mean, but that's sort of independent of what we're talking about here. Like you can still set up an MQTT broker to require authorization, right? You need a password to get in, and the messages themselves can be encrypted. You can send an encrypted message that can only be decoded, encrypted at one end and decoded at the other end. So I guess there's double security that way.
Yeah, yeah. No, this is great. You know, great technology, and it's how the world goes. You know, ahead. You know, we small is beautiful.
Agree.
That's what they used to say in the old days.
Do you still have a question, Kurt?
Yeah, I'm still thinking about this issue of bootstrapping up a mesh in Victoria, and I'm wondering if there's opportunity for perhaps a group buy and getting together and burning the images and bootstrapping as a group rather than individually.
I think the answer is yes. If you want to take the leadership on that, Kurt, that would be great. And I can put something out. I'll think about it and maybe bounce some stuff off you, Kurt. Via
I think what we need first is just a list of people who might be interested in doing that.
Exactly. No,
we can go organically from there.
Is it appropriate we be continuing the recording?
You're muted there, Andy.
I can stop the recording if you want.
Yeah, okay. You can stop it now. It's fine.